Hello, I am Greg Risser, a PhD candidate at Drexel University in Philadelphia. I work in Dr. Kara Spiller's Biomaterials and Regenerative Medicine Lab. My research focuses on delivering immune cells called macrophages and immunomodulatory biomaterials to a site of injury with the goal of supporting angiogenesis, the growth of blood vessels. To accomplish this, I load biocompatible PLGA polymer microparticles with a protein that can direct host and/or injected macrophages to behave in a manner that is beneficial for angiogenesis. I target macrophages because we believe that macrophages can direct angiogenesis by promoting the sprouting of new vasculature as M1 macrophages or helping to mature and support new vessels as M2 macrophages. And so it's thought that macrophages can achieve these different functions by changing their behavior in response to external stimuli, such as proteins. And so one protein that is believed to direct macrophages to mature and support angiogenesis is interleukin 4 or IL-4. And so IL-4 is what I selected to load into my microparticles to modulate macrophages. To test my treatment of IL-4 loaded microparticles and macrophages, I injected them into a model of hindlimb ischemia, or HLI, wherein the blood flow to the calf is cut off by ligating the femoral artery and vein, creating an area in need of angiogenesis as there is no more blood flow. So first, I generated the HLI injury on day 0. Then, as my treatment focuses on supporting new vasculature, I waited 3 days to allow for the initial sprouting of blood vessels before injecting my treatment to promote vessel stabilization. 7 days after the injury, mice were sacrificed and analyzed for how macrophages physically interact with blood vessels, macrophage expression of key markers, and angiogenesis. So we were very excited to see how macrophages in red are reaching out and grabbing multiple blood vessels in cyan. And so where these macrophages could be helping to anastomose or link these vessels they're physically interacting with. Additionally, we saw that macrophages are wrapped around larger, more mature blood vessels, potentially indicating a role in the vessel stabilization. So looking at the markers that macrophages express, we can see that the treatment induced macrophages to express M2 markers at higher levels and M1 markers at lower levels, showing modulation of phenotype to a more supportive behavior. Finally, looking at the blood vessels themselves, we can see that while the density of the blood vessels remained the same, the perimeter and area of the blood vessels mildly increased with the IL-4 plus macrophage treatment. And this shows that the treatment modulated macrophage phenotype and in turn had subtle effects on the maturation of blood vessels. So future directions for this treatment could be to test other types of M2 promoting proteins or to test how promoting M1 behavior increases early sprouting of blood vessels. So with that, thank you for your time and to the Biointerfaces committee for allowing me to pitch.